Hello and welcome to this brief overview on gear design. Gears are used in various mechanical devices to transmit rotary motion between two shafts. Designing a gear involves several critical considerations. Step 1. Determine the purpose. First and foremost, it's important to determine the purpose of the gear. Do you need to change speed, torque, or direction? The purpose directly influences the type and size of the gear you'll need. Step 2. Select gear type. There are several types of gears: spur gears, simple and used for parallel shafts. Helical gears, similar to spur but with a helical tooth form, they offer smoother operation. Bevel gears, for intersecting shafts. Worm gears, for large speed reductions on non-intersecting shafts. Step 3. Basic gear terminology. Diameter pitch, also known as PD, is the number of teeth per inch of the gear's pitch diameter. Module, also known as M, is the ratio of the pitch diameter to the number of teeth. Pitch circle is an imaginary circle where the gear teeth engage with another gear. In Step 4 of gear design, several essential formulas are highlighted. The pitch diameter, also known as D, is calculated as D equals N divided by PD for inch units, and D equals M times N for metric units, where N denotes the number of teeth. The circular pitch, also known as P, represents the distance between corresponding points on consecutive teeth and is given by the formula P equals pi times D divided by N. Additionally, the gear ratio is determined by dividing the number of teeth on the driven gear, N2, by those on the driver gear, N1. In Step 5, the primary design considerations for gears are discussed. The gear's strength is vital, necessitating the selection of appropriate materials and dimensions to endure the forces it encounters. Over time, gears experience wear, with factors such as tooth profile, material choice, and surface finish influencing wear resistance. Additionally, backlash, defined as the play or looseness between paired gear teeth, is critical to account for, especially concerning thermal expansion and effective lubrication. In Step 6, the emphasis is on safety factors and their application in gear design. Gears typically incorporate a safety factor to ensure resilience against unforeseen loads, with the specific factor contingent on the gear's application. For example, the safety factor for a clock gear will differ significantly from that of a car transmission gear. Conclusion: to design an effective gear, you need to consider the purpose, type of gear, critical dimensions, and key formulas related to pitch and gear ratio. Once designed, it's also essential to test the gear under actual or simulated conditions to ensure its performance.